Let's take a look at how we find the second derivatives of functions that are expressed either as products or as quotients. So we're going to find the second derivative of the following functions. So we'll start off with a product. We'll give ourselves f of x equals x times the cosine of x. Well, in order to take the second derivative, there is no shortcut to this. It really is a matter of you've got to take the derivative and then you've got to take it again. So let's apply the product rule. We know that f prime of x is equal to x times the derivative of cosine of x plus the cosine of x times the derivative of x. That's what the product rule tells us to do. Now the derivative of cosine is negative sine, so I know that f prime of x is equal to negative x sine of x. And then if I take the derivative with respect to x, that's just 1, so this is plus the cosine of x. So there's its first derivative, and now we're going to take the derivative of it. So f double prime of x is equal to, now then if I look, I still have a product right here, so I'm going to have to apply the product rule. I'm going to go ahead and take that negative out like I can with any constant multiple. So this is the derivative of x times the sine of x. I'll use the product rule right here. Now when I take the derivative, I'll go ahead and write out what we're going to do here. I then need to take the derivative of cosine of x, which is going to be something I already know. I don't need to apply any other special rule. So let's take our product rule here. So our product rule says x times the derivative of sine of x plus the sine of x times the derivative of x. So there's my execution of the product rule, and the derivative of cosine of x right here is minus sine of x. Now then I need to take these derivatives and then we'll deal with the negative and see how we can simplify it. So I've got a negative outside. I've got x times the derivative of sine of x. Well, that's going to be x times the cosine of x. And then here I've got sine of x times the derivative of x. Well, this is just 1. So this is plus the sine of x minus the sine of x. Now then, if I distribute this negative, I get negative. So let's go ahead and write our answer here. The second derivative is equal to negative x cosine of x. And if you look here, I get negative sine of x minus sine of x. Those are actually like terms that I can combine and say that is minus 2 sine of x. So I actually, even though you would think maybe, oh wow, taking the derivative after we already used the product rule would be challenging, you can see here it actually wasn't too bad of a second derivative to take. Now then, let's take a look at a quotient here. Let's look at f of x equal to x over x minus 1. Now then, this is one of the reasons why we tell you, if you can split this up, you should, because you're already probably in your mind thinking, oh my goodness, a second derivative of a quotient might get nasty. If you could split this up, definitely you want to do that. However, in this particular case, because it's a binomial in the denominator, there's not a whole lot that I can do. So let's go ahead and apply the product rule, or excuse me, the quotient rule, to say that f prime of x is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. All right, so let's take a look at what we get here. I get x minus 1 times the derivative of x. Well, that's 1. So this is going to be x minus 1. X times the derivative of x minus 1. Well, this derivative is also 1. So this ends up being x minus 1 minus x over x minus 1 squared. And so what we get for f prime of x, these x's divide off, and I get negative 1 over x minus 1 quantity squared. So now I need to take the derivative of this function. And you would not necessarily be wrong. In fact, you wouldn't be wrong if you applied the quotient rule here. But there is an easier way to take this derivative. if I take a look here, especially because I have this numeric term right here, I can rewrite this as a negative exponent. Let's take a look at what we get when we do. So let's rewrite, again, this is f prime of x. I have not taken the second derivative yet. I'm just rewriting this with a negative exponent. It is negative x minus 1 to the negative 2. Well, this sure looks like something being raised to a power now, and I can use the power rule to take the second derivative. And I can spare myself having to use the quotient rule a second time. So f double prime of x, I can multiply negative 2 right here. I've got some function raised to a power. So the negative 2 comes out, that becomes positive 2, x minus 1. I reduce the power to negative 3. And then one important step I want to make sure that you know is there is I need, because I'm talking about a function of x being raised to a power, I need to apply the chain rule here. I need to make sure that I'm addressing the derivative with respect to x of x minus 1. Now then, this happens to be 1, so it's not going to impact the final answer, but you need to know that we really have that with us here when we're talking about a function of x being raised to a power. So again, I don't want you to get out of the habit of forgetting the chain rule. Now then, this is 1, and so if I rewrite this, taking care of my negative exponent, I get f double prime of x equals 2 over x minus 1 quantity cubed, and there's the second derivative. So you'll notice we had to use the quotient rule the first time, but then we actually kind of caught a break and we didn't have to use the quotient rule twice in order to find the second derivative.